Hi everyone. We are going to go through this PowerPoint called Lenses and Focal Length. You can also find this PowerPoint in this week's module. So be sure to watch this video. You'll be sort of listening to me, although you can't see me. And um, you will watch me kind of go through this PowerPoint, and I'll try to explain things as I click through everything. Um, All right, so let's get started. Lenses and focal length. It's how the focal length of the lens affects your image. There's one thing I need to change right here. So you'll have to remember that this needs to be changed in the version that's already online for you. The table of contents for this lecture is how lenses bend light. We'll look at normal, wide angle, and telephoto focal length, and the three things that affect depth of field. First, let's talk about bending the light. And I want to start with this image right here. I take you into presentation mode. This is the inside of the camera, which I kind of went through and I at least drew it on the board for you. This is inside your lens, and you can see that there are different pieces of glass inside your lens. You have a concave glass and convex glass. And as the two pieces fit together, as you can see, as they do inside these illustrations, they basically they focus the light. That's their job, is to focus, is to bring everything into focus. And the concave lens, as you can see, the light comes in one direction and spreads out. And in the convex, the light comes in one direction and bends it towards the center. And together that works to focus the light. So there are anywhere between 5 to 7 pieces of glass, also known as lenses, inside the actual lens that connects to your camera. And when the two pieces of glass, the convex glass or lens and the concave lens, when they're placed next to each other, they focus the light. That is their job. Lenses are responsible for two things: focusing the light and letting in light in terms of volume. And of course, we know that they let in light in terms of volume. That is called your what? Your aperture. The maximum amount of light a lens lets in is called its maximum aperture. And the example for that is basically the widest open f-stop on your lens is its maximum aperture. How well the lens focuses is called its resolving power. If you shoot sports or action, then you want a lens with fast resolving power because it focuses faster. So go ahead and notice, you may have already noticed on your own camera, how kind of slow or laggy it is whenever it is trying to focus on something. And I've definitely mentioned that in the dark, like if your camera can't see what there is to focus on, then it really has trouble focusing, and it will kind of go zzz, 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 as it tries to find something to focus on. But with our cheaper lenses, it has really slow resolving power, and it just takes a little bit longer to focus, especially on, I would say, longer lenses. So if you have a telephoto lens that's like 75 millimeter to 300 millimeter, but wasn't a super expensive lens, or just came with your camera when you bought it when you first bought it, then it probably also has a slow resolving power. It really takes a lot of cash to get a really fast lens. A lens with a really wide open maximum aperture and a fast resolving power. It'll put you back about, $1,800 to $3,500 on one of those kinds of lenses. Focal length is measured in millimeters, and the numbers are generally found on the outside ring of your lens. I've definitely pointed these out before, but we haven't really gone into detail, so that's what we're going to do in this lecture. So those, I think they're generally white numbers on the outside of your lens, and there's a little white line that kind of lines up or is right next to the number 32 or 35. Okay, so you want to just look at that and notice where it is on your lens. Normal focal length is based on the size of the sensor in the camera. So normal focal length is not the same. It depends on the size of the sensor in your camera. So we all have 35 millimeter style digital cameras. 35 millimeter film, right? That's the type of film that we all used to shoot before digital cameras came onto the scene. And the normal focal length for that style camera, for 35 millimeter film cameras, the normal focal length was 50. And that's going to be important here in a second. But besides 35 millimeter style cameras, there are other cameras before digital came about. You had medium format cameras and large format cameras. And we still have these today. They're just incredibly expensive, especially if they're digital cameras. But if you can get a medium format film camera for just a few $100s, same thing with a large format film camera. But that means that the film is actually 6 centimeters by 7 centimeters on a medium format, or it's 4 inches by 5 inches on a large 4x5 camera. So that sensor, right? If you relate that to the size of the sensor, on a 4x5 digital camera, the sensor would also have to be 4 by 5 inches. So it's much, much bigger. So the normal focal length on a sensor that is larger is a much higher number focal length. So, okay, so let's just step back a second and talk about our types of cameras. The sensor in the camera is not the same size on every camera, right? The camera on the phone has a sensor, but it's very, very small and tiny compared to the sensor in your DSLR. So that's kind of going the other direction. The sensor in our cameras is very tiny, and so the f-stop and the focal length and everything on our camera phones is our phone cameras is much different than it is on our DSLRs. All right, so let's take a look at this, and then we'll look at some text to help us understand. You have here on the upper left a crop sensor and a full frame sensor. And you can immediately already see with the lens taken off that the full frame sensor over here on the right, this Canon EOS 6D, is larger than the Canon EOS 80D style camera. You can see that it's smaller on the crop sensor. And then basically we have what you have here is they basically took this image of 35 millimeter film and placed the full frame sensor inside the 35 millimeter film. So that's what these are. These are the sprockets of the 35 millimeter film. And so that shows you that the full frame sensor is the same size as if you were shooting 35 millimeter film. And then the cropped sensor is not the same size as if you were shooting 35 millimeter film. It is indeed smaller. And what we have and I know not all of us are shooting with the same cameras, but if you have a Nikon, a Pentax, or a Sony, or a Canon, you have a sensor that's called an APS-C sensor. And you see that these lines here point to the size of that sensor, right in here, this sort of olivey green and forest green color here. Shows you how large the sensor is compared to this one on the outside, which is the 35 millimeter full frame. It's much, much larger. So whenever you're buying a full frame digital camera and you're spending $4,000 on it, $3,500 to $4,000 on it, you are getting a much larger sensor, which basically, I mean, what's the point of having a larger sensor? It's all about how much detail and data that you are able to collect. So the colors are more vibrant, the gradation of skin tone is much more clear, the ISO ability on those cameras, on the full frame cameras, is much better. So you can shoot at much higher ISOs and get much less digital noise. Then the list goes on and on. I mean, the quality of the image is just hands down so much better than if you had a crop sensor. Even though I know most of us start out with the crop sensor cameras because they're are more reasonably priced, to say the least, right? Okay, so let's see if I can go back to this. Okay, normal focal length. There are, and I'm going to repeat a couple of things. I'm just going through what I have here. There are cropped sensor DSLR cameras and the full frame sensor DSLRs. That's what we were just looking at. Normal focal length on a full frame is 50. Normal focal length on an APS-C cropped DSLR is 32 or 35. So what they did is that they basically created a ratio. It's a math, they did a little bit of math. If we go back to this one and we see, this one over here, the crop sensor 1.5 times to 1.0. If we multiply 1.5 times 32, you get like 49.3 or something like that. And that's how they came, that's basically the crop factor is 1.5 on an APS-C size sensor. And that's how they get those, that's kind of how they come up with those numbers. So, but the main thing for us to remember is that normal focal length on a full frame is 50. Normal focal length on a cropped DSLR is 32, or I would also accept 35, because most of the time on your lenses, that little white mark is at the 35 millimeter mark. It is all to create the same effect as if you were shooting with the full frame. Okay, so let's go back to this image. If I am the image on the bottom right, if you and I are standing in the same exact spot, right next to each other, and we're photographing this couple sitting on this blanket in the woods. I have a full frame camera and I'm shooting at 50. You have a crop sensor and you shoot at 50, right? You will get a cropped view of the scene. I will see all the way to the edges of this image, but you at 50 will get a cropped view. That's basically what that means when they say it's a cropped sensor. Because if we're both shooting at 50 millimeters, then your view is cropped. So if you want to get the same view as me on a full frame, you need to shoot at 32. Then you would also get this entire scene from edge to edge. Normal focal length does or creates the following effects. It's the true perspective of what the photographer sees. And it doesn't affect depth of field as much as telephoto or wide-angle focal lengths. Let's look at wide angle. How do you know if you're shooting a wide-angle focal length? Well, it is any number that is lower than your normal. So if your normal is 32, any number below that is considered wide angle. And it has the following effects. It elongates the scene, making things appear farther apart. It emphasizes great depth of field, so it brings everything into focus, right? And it distorts the most. Let's go ahead and look at a few examples of that right now. Wide angle examples. I pulled these from the web, so that's why this one on the right isn't exactly sharp, but you do get the effect of especially the distortions, especially this image on the right. Notice how it does seem like a distorted angle of view on this whole scene. Seems as though this is incredibly far away, when if you were in that room, it probably isn't. But the wide angle distorts that sort of the elongation of the scene. And things appear farther apart. Even in this scene over here on the bottom left, everything seems so far away and at a great distance. Everything is sharp. And the image on the top from underneath the Eiffel Tower, it's just an incredibly wide angle shot. I mean, you're seeing, and it's fairly distorted as well. Okay, so those are the examples for wide angle focal length. Telephoto. Telephoto is any number that is higher than your normal focal length and has the following effect. So any number higher than 32 is considered telephoto. Now, it may not be as telephoto, right? Like if you're at 35, that clearly is not going to emphasize shallow depth of field a whole lot. But if you're at 105, that's much higher than normal. So you would emphasize shallow depth of field even more the higher your focal length number goes. It also compacts the scene, making things appear closer together, and it distorts the least. Here are some examples of that. Now, we already know that it does create shallower depth of field. So like with these images, this image of the man and the little boy, you have shallow depth of field because that background just goes very indistinct, right? Same thing with the birds and for this butterfly. But something we haven't really discussed is how this example here is at 800 millimeter focal length, shot with this sort of off-brand camera called a Samyang, or a Samyang lens. And I can tell that it is telephoto even without knowing that it's shot at 800 millimeter focal length because how everything is packed together. It seems as though someone shot this at a distance. I mean, especially notice the shallow depth of field of these branches that are sort of more in the foreground, and how everything looks compact and closer together. Same thing for this image of with this giant sort of cruise liner in the background. It looks like it's on the highway. It looks packed together with the buildings. It just spatially doesn't make a whole lot of sense. It seems somehow very flattened out. And so that can only happen with the telephoto lens. And it distorts the least. So those are the few things that really those are the few effects that really come with shooting with a telephoto focal length. And of course, we know the three things that affect depth of field, right? They affect your overall depth of field in your image. Focal length is just one part of it. So it does depend on your f-stop. So if we're reminded, and I can go into a little whiteboard situation here. Okay. If you're at f4 at it doesn't really matter what the shutter speed is, right? Because your shutter speed has nothing to do with your depth of field. Say 1/125. Same thing with ISO. Doesn't matter. Doesn't affect your depth of field. But your focal length is 105 millimeter. This would give us what kind of depth of field? It would give us shallow. The last thing that affects your depth of field is your camera to subject distance. So that will also have an effect. At f4 though, and at 105 millimeter focal length, because you're shallow depth of field f-stop and you're very zoomed in, you're shooting telephoto, you will have pretty good shallow depth of field in this image. Now imagine if you're 10 feet away from your subject or 15 feet away from your subject, you're still going to have shallower depth of field in that image. If you're 5 feet away from your subject, a little bit closer, then it will create even more shallow depth of field. That background will just go totally indistinct, and you'll have those bokeh highlights in the background. If you're at f22 at, let's pretend 1/125, and your focal length is 24, this is absolutely great depth of field, right? Great depth of field for this one because you're at a high f-stop number, which already increases or emphasizes your greater depth of field. And then your focal length is at 24 millimeters. So you are wide angle, and that is going to definitely elongate the scene and emphasize great depth of field. Okay, let's go back to the PowerPoint. And then I'm back to my examples that are at the end of the PowerPoint. Okay, that about covers it. If you have any questions at all, feel free to send me an email and let me know your thoughts. I hope this was helpful, and this will be a part of your quiz that you have this coming weekend.